Alright, let's look at the practice exam 2, problem number 8. Alright, so we have inverted conical water tank. So it's a cone. So it looks like that, and it's inverted. Alright, then the height is 9 feet. So you look at the height here. It's 9 feet there, and the radius 6 feet. So this is right here is 6 feet. All right, and right through the hole at the vertex, so right at the bottom. So the water is kind of coming out. So water is coming out like that at the rate of 4 cubic feet per second. So 4 cubic feet per second. Right. What is the rate of change of the water depth when the water depth is 5 feet? Right. So the water is let's say, so here is the water level, and at this point right here is 5 feet. Right, then we want to know how fast the water depth is changing. Right, so this is the water. Alright, so let's try to find the equation. So we are looking at the rate of change of the volume here. So remember that the volume of the cone is 1/3 pi radius squared times height h. Alright, so let's give it a variable here. So here, the depth of the water, since I don't want to use d because it's confusing with the derivative, so I'm going to use h like a height. So this is going to be h right here. Alright, then once you know h, we can actually make find the expression for the radius, and the radius is actually here. So this is r right there. Right, so we can use the a similar triangle. So we look at the big right triangle here. So triangle who has 9 feet here and 6 feet there. So that's this triangle right here. And I'm going to use this similar triangle, so it's a little smaller. And this is the h right here, and this is r. Alright, so we can find, you know, since these are similar, because you have the same angle here and the same angle here, those are right angles there. Alright, so we can express the ratio. For example, r to 6 is equal to h to 9. Right? Then you can just multiply through by 6 to get r can be written as 6 over 9h. But we can simplify, so divide by 3, 2, divide by 3, 3. So h is really the same thing as 2/3 h. Alright, so we can plug this guy into the formula here, right? So that we don't have to use two variables. So in this case, we have 1/3 pi, right? Radius is same thing as 2/3 h squared, and then you have another h from here, right? So if you simplify that, that's going to be, right, 2 squared would be 4, and you have a pi, Alright, then you have a 3 square and another 3, so it's 27 on the bottom. Then you have h squared and h, so it's going to be h cubed. Alright, so this is the volume of this body of water. Alright, then we know that we can just take the derivative of that. Alright, dv with respect to time, right, in second. And then 4 pi over 27 is just a number. Right, so the derivative of h cubed would be put 3 in front, h, subtract 1 from the power, so it's squared, then you multiply by dh over dt. Right, since we're taking a derivative with respect to t, we get that. Alright, then we can simplify a little bit. So you have 3 and 27 cancel out, so you get 9. Alright, then we have, let's see, since we're looking for dh over dt. Alright, so I'm going to go ahead and solve for this. So this is going to be, right, I'm going to divide through by, right, I'm going to give it a 4 pi over 9. And also h squared. So I'm going to just divide through by 4 pi h squared over 9. So you're going to get, let's see, 9 over 4 pi h squared dv over dt is equal to dh over dt. Right, so all I did was instead of dividing by 4 pi h squared over 9, we multiply by 9 over 4 pi h, just the reciprocal, which is equivalent. Alright, since we're looking for the rate of change of the depth, so dh over dt, so we get this, dh over dt is equal to, right, so 9 is a number, and 4 pi is a number, right? H at this point, h is 5 because you know, the depth is 5, so 5 squared, right? Then times dv over dt, right? Since the water is drained at the rate of 4 cubic feet per second, so dv over dt would be -4. So we put -4 there. Right, so you can see that there's a 4 on the bottom and 4 on top, cancel out. You end up getting, right, there's a -9 on top, and 5 squared would be 25 pi. Right, so this is going to be feet per second. So negative indicates that the water depth is going down since you're draining the water. And at the rate of 9 over 25 pi feet per second. Alright, that's it. I hope that this was clear.